The next topic in geometry is the angle bisector theorem. And we all know that angle bisectors are devices that split an angle into two equal parts. In other words, bisecting it. So we've studied that word before, but when it happens in a triangle, and something additional interesting happens. And so there are two things you need to know about angle bisectors, specifically in triangles. Number one, so these are going to be two things to know. Number one is that it splits any angle into two equal parts, and the second thing has to do with the side lengths that result are proportional. So that's the interesting thing. The side lengths that result are proportional to each other. And I have this diagram right here that explains this. Let me zoom in. Okay. So in this diagram right here, so AD has bisected angle BAC. So this angle here, I'm just going to trace it so that it's clear. So this angle here, angle BAC, AD has bisected it so that this and this are congruent. Okay? So those two angles are congruent now, and then what happens, this is what happens. BD, I'm going to get some colors here to make this clear. So BD, which is this side right here, okay, so BD is to DC. So BD is to DC as AB is to AC. I think that's really cool. Okay, AB is to AC. All right. So, in other words, what this is saying is that BD is to DC as AB is to AC. They're proportional, and so each one of these is a ratio, and the ratios are equal to each other. Ratios are the same as fractions, so it's just setting it up like that. And so if we were to do this with the colors, we could set this up. Let me just write these in darker. Just write these in darker. So fraction equals fraction. BD is the blue. DC is the green. AB is the bright green. And AC is the pencil. Okay, so notice what this means. It means that BD and AB are on the same side of the fraction. So BD and AB. So basically you're looking at BD and AB being on the same side of the fraction. Okay? So these are same side of the fraction, meaning that they're both on the top. See how they're both on the top there? And they're on the same side of the triangle. And the same thing goes for the bottom of the fractions. The DC, which is here, is on the same side as the AC. So you can kind of think of it that way. Of course, it doesn't really matter which one of these you write on the top or the bottom, because you could just take this whole thing and go to reciprocals, and it would be exactly the same as writing DC over BD equals AC over AB. Those are completely equivalent statements. Okay? So let's look at a couple of examples here. All right. So what if we wanted to find the measure of BDC, which is again here, BDC, right there, right? BDC. If measure of angle 2 is 20, okay? But notice that each figure shows a triangle with one of its angle bisectors. So we know that DP is an angle bisector, and we know that angle 2 is 20. So if that's 20, then this has to be 20. So the measure of angle BDC equals 40. Okay? Same kind of a thing here. Find the measure of angle 2 if ZXY is 78. Well, if the whole thing is 78 and 2 is half of it, then we need to divide. Half of 70 would be 35, and then of course we're going to add 4 more, so we're at 39 degrees right there. Okay, let's do one with some algebra in it. Find x if the measure of angle 1 is 16x. So we know the measure of angle 1 is 16x. And UST is 33x minus 2. Well, if we know the whole thing is 33x minus 2, and that is 16x, we know this has to be 16x because SP is an angle bisector. So we know that 33x minus 2 equals 2 times 16x. I've just doubled it, right? I've doubled the 16x right there. So this is all equal to 32x. And if I subtract 33x here, of course those go away, and I have negative 2 equals negative x. So 2 equals x. And that's what I was looking for because the direction said to find x. So there's x. Okay. Let's look at a couple more examples here. How about this one right here? I'm going to do this one. So find the measure of CAB. So we need to find CAB. If the measure of angle 2 is 35x plus 1, so this is 35x plus 1, and measure of angle 1 is 37x minus 1. Well, if AP is an angle bisector, then this has to equal that. So we know that 35x plus 1 equals 37x minus 1. Okay, so let's subtract 35x and add 1. So we'll add 1 and subtract 35x. I'm just doing 2 steps at the same time. So those go away, and what am I left with? I'm left with 2 equals 2x. So so dividing by 2, 1 equals x. So now that we know x, we can plug this back in. So 35x plus 1, I'm just going to plug it in there. Whoops, sorry, I'm going to plug it into the top one. So 35x plus 1 now equals 35 plus 1, which equals 36. So if 36 is this, then the whole thing, so that the measure of angle CAB, which is what we wanted to find, is twice of that. So that's 72. Okay? And the last thing I want to do is a couple of these that show the proportionality stuff I was talking about, the proportional sides. This is kind of different. So remember that we're setting up this fraction here, right? So that we have the same stuff from the same side of the split on the same side of the fraction, okay? So using that as our guideline, if this is an angle bisector right here, and again, it doesn't matter if I list the BD, which is it doesn't matter if I list the BD on top or the AB on, well, excuse me, the AB and the BD just have to be on the same side, okay? But it doesn't matter if I put this on the top or this on the top, okay? So if I'm looking at this diagram here, and all I'm going to do here is basically just match up and make sure I've got everything where it should be, okay? So let's just match it up here. I'm going to pull this down a little bit further just to make it easier to see everything. Okay. So this is what we're doing, right? This is what we're doing. So if this is what we've got, then BD would be either the question mark or the 4. It doesn't matter. So I'm setting up a ratio, or excuse me, a proportion. And so I'm either going to put 4 or question mark on top here for BD. So let's just call this the highlighted side. So see, and it doesn't matter which way you do this, because the proportions aren't biased towards one side or the other. They all mean the same thing. So let's just say that's my highlighted side. So BD is going to be 4. And if BD is 4, okay, then DC is the green. Then DC is the green. And so DC is going to be the question mark. All right, see how the top here, or excuse me, see how the first fraction here, BD over DC, is BD over DC, is 4 over, excuse me, oh my gosh. I'm talking through this and I'm making mistakes, trying to slow myself down here. So this would be 6. No, DC, oh, excuse me. Okay, all right. Let's look at this. I want to talk through this a little bit more before I jump into this. BD and DC are the result. BD and DC are the result of splitting across this third side here. So this is 4, and this would be the question mark. Yeah, that would be the question mark. And then the AB would be the 6, and the AC would be the 3. So essentially what you're doing here is you're matching up. So the 4 and the 6 should be on the same side of the fraction, and they are, because they're from the same side of the triangle. Okay? And so then if we wanted to solve for this, we could take the whole thing to reciprocals. Excuse me for yawning. We can take the whole thing to reciprocals. Okay, I just took the whole thing to reciprocal. I can bring the 4 up, which gives me 12 over 6, which just gives me a 2. So question mark is 2. Alright, but let's make sure we understand the setup, because that's what's going to make this successful. So when you're looking at the side across from the angle that you've bisected, so notice that this here is the side across from the angle that has been bisected. That consists of the first fraction. It doesn't matter which fraction, but that is one fraction by itself. BD over DC. So whichever way you want to think about it, if you want to set up a fraction first or set up all the numerators first, it doesn't matter. But one fraction is going to consist of the side that was split into these proportional parts, and the other fraction is going to consist of the sides of the triangle AB and AC that were not touched by the bisector. Okay? Okay. So let's move on to another example. Okay. So here, the entire side is the question mark, but this portion right here is 6. So notice that this is 6. Just this part right here is 6. So if the whole thing is the question mark, then the remainder right here, this part, that part right there, is question mark minus 6. We can treat that as an expression. It's question mark minus 6. Okay. So if we're setting up our fractions, let's set up the fractions here. So we have fraction equals a fraction. Remember, everything on the split up side, everything on the split up side makes up one fraction, BD over DC. So in this case, it's going to be 6 over question mark minus 6. Okay, and then 6 would go over to 8. That's on the same side here, 6 to 8. So that's on the same side of the fraction, and it leaves us with a 4. So if I need to get rid of this in the denominator, I can multiply it up, and I could also multiply the 4 up. I think that'll be helpful. Well, you know what? 8 over 4, let's just be smart about this. 8 over 4 is just 2. So let's just call that 2. So if we multiply this up, then we'll have 6 equals 2 times question mark minus 6, right? And dividing the 2 across, I'm going to have 3 equals question mark minus 6, and then adding 6 to both sides gives me 9 equals question mark. So there's my question mark right there. Let's do another one like this. So the whole side is 22. There's the question mark. So the question mark is that part. The question mark is that part. So this part up here is 22 minus question mark, and we can treat that as a little expression. So if we're setting up our fractions, okay, we're setting up our fractions, the sides across from the bisector are on the same fraction. So 22 minus question mark over question mark. 22 minus question mark over question mark. And then the 22 minus question mark corresponds to that, so that goes up here, and this corresponds to the 16 because that comes down here. It's on the same side of the triangle. Okay. I want to reduce, I can reduce this fraction right here. That would give me 14 over 8, which I could have reduced further, excuse me. 28 divided by 4 is 7, and 16 divided by 4 is 4. So that's actually what that this thing equals this thing. So I can cross multiply. I've got two different variables here. I got to get rid of that. So I'm going to cross multiply everywhere, and I'm going to get 22 minus question mark times the 4 from the other denominator equals 7 question mark. Multiplying through here, I don't see a better way to do this. So it looks like 88 minus 4 question mark equals 7 question mark. Oh, I see where this is going now. So plus 4 question mark, those will go away. So we have 88 equals 11 question mark, and of course dividing by 11 leaves us with 8 equals question mark.